Greetings to all of you. In today's session, we are going to discuss about intermediate chemistry, where this content is helpful for international entrance and competitive examinations, India level JEE mains, JEE advanced exam, NEET entrance examination, Telangana EAMCET and AP EAMCET examination. The people who are preparing for any other competitive exam, for all these, the content will be very much helpful. This is the session derived from various question papers which already conducted in the previous years, and a detailed explanation will be provided to you. Definitely this kind of discussion will helpful for your effective preparation towards either entrance or competitive exam. Let's go with the question number 1. Write the IUPAC name of the following compounds. These many compounds are provided to you. Among all, first one is a simple hydrocarbon with side branches. And second compound is the ether compound with side branches. Third compound is the cyclic one with the ether compound in this, right? So for all these compounds, we have to go for IUPAC nomenclature. In accordance with the International Union for Pure and Applied Chemistry, there are certain regulations and guidelines in order to name the organic compounds, right? So parent chain should be longer, and the naming of ethers given as alkoxyalkane. And here cyclic compound when taken here, that cyclic compound included with this alkoxy, and this will become a side chain over here, right? So to name this compound, let's go with the one by one. So if you consider the compound number 1, where we have the parent chain length, let's go with this side. For example, 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon chain is there. Let's come from this end. 1, 2, 3, 4, 5, 6, 7. If you count in this manner, the chain length is becoming 7 only. But here, thumb rule is the longest chain is the highest priority. So that we have to go for 8 carbon chain. Moreover, in the 8 carbon chain, so wherever branches are there with the least number is preferable. So that we will start numbering from this right end of this organic chain. So that numbering will be started with the carbon of right side 1, 2, 3. Third carbon is having 2 ethyl, right? So we can mention 3, 3 diethyl, 3, 3 diethyl, and on the fourth carbon we have methyl. Fourth carbon methyl is there. Fifth carbon is having a isopropyl. So that fifth carbon we can mention isopropyl, and the longest chain is 8 carbon, so that octa is the prefix. So that octane, being all the carbons are saturated, single bonded, we can say octane is the name of compound, right? So here, in that segregation will be in a manner, alphabetical order we need to follow. Diethyl, eth will come first, followed by isopropyl. I will come next in accordance with the alphabetical order, and M will come next. So we have to arrange all these 3, 3 diethyl, 5 isopropyl, 4 methyl octane. So longest chain is 8 carbon, so that octane is the name. This is the way we can mention the IUPAC nomenclature for the organic compound. Let's go with this ether. Whenever ether was taken, longest chain is taken. Here 2 carbon chain is there with oxygen, 1 carbon chain is there with oxygen. So that alkoxy will be taken as the ethoxy. And this ethoxy, if you are going with the 1, 2, 3 carbons, 1, 2, 3 carbons, 3 carbons is the longest rather than 2 carbon chain. So that we can say it is the propyl rather than ethyl. 1, 2, 3. 3 carbons taken into the parent chain, and the side chain will be, so propoxy, methane. On this propoxy we have first, second. The second carbon is having methyl, so that mention 2 methyl. And moreover, oxygen is also there on that second carbon, so that 2 methoxy. So alkoxy, alkane you can mention, no? Alkoxy will be the methoxy, where it is second carbon, so that 2 methoxy, and the parent chain is prop. And moreover, it is the singly bonded, we can say propane. Okay, on second carbon methyl to methyl, and on second carbon methoxy to methoxy, and parent chain propane, so that 2-methyl 2-methoxypropane is the IUPAC name of compound number 2. Let's go with compound 3, where we are having side chain methoxy on this cyclic compound. This is the 6 carbon ring, so that we can say cyclohexane. Okay, alkoxy alkane, methoxy cyclohexane. Methoxycyclohexane, simple to mention the name of this compound. This is the way for IUPAC nomenclature. Let's go with the another question. The SI unit of temperature is, it's a very fundamental question. Temperature unit in the SI units to be discussed: Fahrenheit, Celsius, Kelvin, centigrade. Right. So here Kelvin is the right answer. The Kelvin is of the 7 SI base units, and among 7 SI base units, Kelvin is one of the unit in order to represent the temperature. And there is a kind of relation between the centigrade and Kelvin scale here. K is equal to, K denotes a Kelvin scale. Temperature is equal to degree centigrade can be added with 273. For example, 30 degrees centigrade, if you want to convert into Kelvin, so the 30 can be added with the addition term called 273.15. So that Kelvin scale temperature is denoted as 303.15 Kelvin. Right. So it's very simple to convert this degree centigrade into Kelvin and vice versa. Right. So this is the way we can go with. Correct answer will be option number C for question number 2. Let's go with the question number 3. It is purely from organic chemistry, and this is the compound of phenol. When para CH2OH, right? We are having CH2OH in the para position. So this is called methylol, para-methylol phenol. Upon treating with hydrobromic acid, the major product will be P. Whenever, so this is called methoxy, para-methoxyphenol. Upon treating with hydrobromic acid, Q is the major product. What will be P and what will be Q respectively? We have to identify both the compounds are having equal molecular weight, because here CH2OH and OCH3, there is, these two are called functional isomers. Hydroxy and ether both are called functional isomers. If this kind of representation is taken, what will be the product with the HBr reagent, and methoxy is there, what will be the product? Same molecular formula, reagent same, but arrangement of, here we have hydroxy, here we have ether. What kind of products we will get? Entirely two different products will be obtained. These many options are provided. We have to go for the right answer for this question. Okay, let's see. The reaction number 1 proceeded with the nucleophilic aromatic substitution. Right? Whenever the CH2OH bond is taken into the consideration, hydrobromic acid without any specific Lewis acid mentioned, so that aromatic substitution might not be followed. Rather, we have to go for side chain substitution only. And if you see CH2OH being the bond is polar and will be cleaved in a considerable way in the presence of HBr, and OH will be replaced with bromo, so that negatively charged hydroxide substituted with negatively charged bromide, hence we can say nucleophilic aromatic substitution. Right. And this is not exactly aromatic substitution, rather we can say it is the side chain substitution. Nucleophilic substitution will be the right representation of first one, first answer. Let's go with the second one, where we have methoxy. This methoxy can be treated with hydrobromic acid. When hydrobromic acid is treated here, this will be followed with electrophilic substitution. That means methyl positive, methyl carbocation can be substituted with a proton, H plus ion over here, because in ether, the electrons whichever present on the oxygen will participate in the ring resonance. That is called mesomeric effect. Lone pair of electrons in the oxygen will go towards the ring. So here there is a bond polarity among the oxygen and methyl, so that here partial negative charge, partial positive charge accorded, partial negative charge accorded on the oxygen, partial positive charge on the methyl, so that we can replace methyl with H plus, and this used to form OH. Okay, so whenever the electrons and the oxygen is moving inside the ring, so whatever bonded electrons among oxygen and methyl are slightly moved towards oxygen, so that oxygen will acquire the partial negative, methyl will be partial positive. CH3 positive can be replaced with H plus, so that we can say it is the electrophilic substitution reaction, and we will get the OH at the para position. So here, when CH2OH hydroxy is there, it is the kind of nucleophilic substitution, OH minus replaced with Br minus. Whenever OCH3 is there, CH3 positive replaced with H plus, so that we will get a hydroxy. So this is the way we can answer, and the right option will be option number B, where you can get OH and CH2Br at para, OH and OH at para, right? Let's move on to question number 4. In question number 4, again it is the part of organic chemistry. The correct product of the following reaction. Here, this is the cyclobutane ring with a double bond over there, and here we have cyclopropyl. Sorry, it is the propyl chain. We are having 3 carbon chain joined with the cyclobutane with the double bond, right? Whenever this is the compound is treated with hydrobromic acid under heat conditions, we are rising the temperature. Whenever temperature rises, what product we will get? If simply addition is possible, one side you can add H plus, another side you can add Br minus, so that we will get addition product either A or B. But this is not the case, we will get the product. So many kind of mechanisms or effects will be operated in order to get the final product, right? Let's go with the detailed mechanism for the reaction. Then only we can understand how can we get the product number D as the final, product number D as the actual product for this whatever equation provided. If you see the mechanism, this cyclobutyl conjugated with this propyl with the double bond can be treated with HBr. Whenever HBr is added, you can add H plus for one carbon atom. H plus when added, there is a origination of carbocation. Here you can attain a carbocation. Everybody aware that cyclic butyl 4 carbons ring will be highly strained. So always it tends to expand the ring, so that according to Bayer's strain theory, cyclopentyl is the higher stable when compared to cyclobutyl. In order to attain the stability, this 4-membered ring will participate in the ring expansion. Being this positive charge is present at tertiary carbon atom will be more stable, and this carbon will involve in the bond formation over there, so that here the new bond formation and here the new carbocation formation is possible. New carbocation will be originated at this carbon, right? And here the new bond formation, so that 4-membered ring will be expanded into stable 5-membered ring. And here is the carbocation. If you observe, this carbocation is the secondary carbocation. Always the stability will be secondary. Tertiary carbocation is more stable than secondary. So that here alkyl group shifting is possible. Methyl group will be moving towards this secondary. Whenever methyl group is coming over here, secondary carbocation is converted into tertiary carbocation. This tertiary carbocation, upon reaction with another bromide ion, we will get the bromo substitution at this ring position. That is clearly given in the option number D. For question number 4, option number D will be the right answer. Let's go with the question number 5. Chlorine is allowed to react with excess of ammonia. In this, 1 mole of chlorine can oxidize Z moles of ammonia. What will be Z here, right? Chlorine allowed to react with excess of ammonia. 1 mole of chlorine oxidize Z moles of ammonia. What is Z here? For that, the reaction is given 3 chlorine, 3 moles of chlorine upon reaction with 8 moles of ammonia, formation of 6 moles of ammonium chloride is possible, right? Along with this, another byproduct is nitrogen gas, right? So in this reaction, this is the stoichiometric equation where balanced equation we got. 3 chlorines upon reacting with 8 ammonia, 6 ammonium chloride will be the product. Then 1 mole of chlorine, how many? 1 mole of chlorine will react with how many ammonia molecules? 1 mole of chlorine will react with how many ammonia molecules? Means 1 get cross multiplied with this one. So that 1 into 8 by 3. So that will become 8 by 3. 8 by 3 is provided in the option number 2. So that for question number 5, option number 2 will be the correct answer, right? So let me repeat once again. 3 chlorines reaction with 8 ammonia, 6 ammonium chloride is the product, right? For 1 mole of chlorine, how many ammonia will be reacted? 1 can be multiplied with 8 and divided with 3. 1 into 8, 8 only. Divided with 3, 8 by 3. 8 by 3 is the right answer for question number 5. Let's enter into last question of the session, question number 6. Choose the correct statement. Ferric, Fe plus 3 is designated as ferric. Ferric ion is more stable than ferrous ion because, okay, in the environment, ferric is found. The oxidation state of iron plus 3 is more stable around the central iron when compared to the oxidation state plus 2 around the central iron. This is because the correct option will be configuration of Fe plus 2 is 3d6 while Fe plus 3 is 3d5. Okay, this will be the right answer. Let's see how can we explain in detail. Okay, so if you enter inside, iron is the electronic configuration here, argon being noble gas taken over here. 3d6 4s2 is the valency shell configuration. It is the d6 system where 3d6 and 4s2 is the outer electronic configuration is there. In order to convert neutral iron into plus 2 oxidation state around the central iron, we have to remove 2 electrons. When 2 electrons removed, 4s level can be losing electrons, so that iron plus 2 is having 3d6. Whenever neutral iron is converted into plus 3 oxidation state around the central iron by losing 3 electrons, 2 electrons from 4s, 1 electron from 3d orbital can be lost, and finally 3d5 will be the configuration, right? D orbital maximum capacity is 10 electrons. Among 10, 5 electrons lost, 5 more are there. Hence, we can say this is half filled. Any element half filled configuration is highly stable. That's the reason why iron preferably exists in plus 3 oxidation state around the central iron rather than iron plus 2. So this will be the right explanation. Based on the half-filled stability, we can explain Fe plus 3 stability over Fe plus 2, right? This is the question from coordination chemistry of inorganic chemistry. So, will be answered in this manner. If you write the expanded form of electronic configurations and how to remove the electrons in order to form the corresponding oxidation state around the central metal, so that we can answer these kind of questions easily, right? So this is the end of today's session. Hope this will be helpful for your preparation. I am requesting you to like the channel, comment over here, and share with the aspirants who are preparing seriously for the entrance or competitive examinations, and subscribe the channel. And thank you very much for your patient listening. Thank you one and all.